Stonehaven is a small town just 15 miles south of Aberdeen. Originally a fishing village, it has a population of around 11,000 people. At the heart of the town is the River Carron and its tributary, the Glaslaw Burn. These rivers have run through the centre of Stonehaven without causing flood conditions for many, many years. A series of man-made alterations to the river course have seen the river level change significantly, so much so that flooding events have occurred. The flood events of 2009 and 2012 resulted in major parts of the lower Old Town being badly affected by flooding. The existing river level monitoring system reports on an hourly basis. However, the graphic shows how rapid the rise in the river levels can be. Therefore, a system that reports river level data on a real-time basis was required. Hence, the formation of the Mackie Young Engineers group dealing with the production of a flood alert system. This graphic shows the various elements of the flood alert system, and the rest of the video will have the young engineers involved explaining their parts. Subsystem 1 deals with the power source and the enclosure located on the river to house the electronics.
Hi, I'm Duncan Ritchie, and my job for the Stonehaven Young Engineers project was to find a way to power the level sensor down at the river. So first I emailed some renewables companies around the Aberdeenshire area, and then I got into contact with JCE and an engineering student where we discussed ideas and bounced back thoughts about the level sensor. We thought the best way to power it would be a solar panel and maybe a water turbine. So I went down to the river and got dimensions of the bars and then completed drawings of the riverbank and sent it to JCE.
Subsystems 2 and 3 relate to the level sensing itself and its transmission from the river up to a Wi-Fi system before it can be relayed to the internet.
Hello, my name's Harvey Craig. My part of the flood project is the level sensing subsystem. We originally used Arduino boards programmed in C, but then we realised that they weren't robust enough for our hazardous environment. We then made an industrial contact who suggested Adam's unit, which is a PLC, a programmable logic controller. We have now installed one and have established a remote connection over the internet. We are working on getting an ultrasound module for this.
Subsystems 4 and 5 relate to the processing of the data on the internet and its subsequent relay on to the next stages in the system.
My name's Alex Patterson, and my role in this project was to program a server to collect and analyse data collected by the level sensing units in the river. I wrote PHP script to collect, analyse and log data from the level sensing units into a database and check if the levels are too high, and if they are, then it sends out a warning to the Arduino units in people's houses so that they can be warned. And I've written PHP script for test purposes that generates a random number instead of taking a number from the level sensing unit, so that we can check that the data is being sent to the Arduino units. And I also intend on building a web application so that people can view previous data collected by the level sensing units, and also so they can check for warnings if they don't have them.
Subsystems 6 and 7 are situated in the end user's household. Subsystem 7 is a bespoke standalone unit that provides a visual display and audio alerts of the river level. Arduino is a modular microcontroller based system running on C. We designed a circuit board on breadboard, converted that into the schematic, and then in turn generated a printed circuit board layout, which was manufactured to produce 5 boards. The students then drilled out and populated these circuits before they were then mounted onto the Arduino boards. These are now ready for programming and testing by the students before they get finally housed in enclosures and situated in end users' houses. Subsystems 8 and 9 was an optimistic idea that the young engineers would be able to piggyback on the local radio station and send data out via a system called RDS.
Hi, my name is Tom Parkhill. It was my job to figure out a way to transmit the information on the river level into people's homes through radio signals for people who don't have internet access. Unfortunately, this is way too complicated for me to understand on my own, so we're looking for somebody with expertise in the area to help me out. I've been helping design the interface for the units that are going to sit in people's homes, and I've also helped to assemble the prototypes for them.
Subsystem 10 was to be the generation of SMS text messages. In the end, this was done with a standalone GSM modem connected to a single float switch.
My name is Brendan Hall, and I've been involved with the level sensing. What we did is we took a day out to populate the boards, so we drilled out and soldered in the pieces. I've also been involved with the planning of the installation of this, which is a float switch mounted inside a bit of scaffolding with some holes drilled out of it. This means that the water can get in, but the debris cannot. We're going to put it out here, which is underneath a carpet shop in Stonehaven, and we're going to get the information from here up into the computer above so it can send out to the locals. Here we have the GSM unit connected up to an Adams unit to send a test signal, and here on the software we can simulate the level sensor to sending out a text. And we can see, or can we? There we go. This phone has now received a text telling it that the river has reached dangerous levels and
This project has achieved many of the goals that it set out to. However, there are still some things needing to be completed as well. A special thanks goes out to the Stonehaven Flood Action Group for their funding support, the JCE Group for their technical advice and support, and for local control engineer Graham Dorrans for his help with the Adams PLC units. And finally, to Morris Cole from Immerse Technologies for generously supplying us with the GSM modem.